Hello, and welcome to the sixth part of the SWORD ITS Best Practice Pattern series. In this part, we will be looking at security options for Azure Synapse. When considering the security of an Azure Synapse Analytics workspace, it is important to understand the various points of exposure and which strategy best secures the various components and risks. Some of the options for securing the workspace are set at deployment. It is important to make the proper judgments on what is required, as these cannot be changed after the fact, except by creating a new workspace. Managed VNet and data exfiltration must be set at the time of deployment and cannot be unset once deployed, or set if not deployed. The more complex security options often require additional Azure components to be provisioned. This adds effort, and these components incur their own additional costs. Protection of Synapse data has three key concepts. 1. Restrict access to the Synapse environment. 2. Restrict access to data and data processes. And 3. Prevent data exiting a secure process and storage. There are a range of mechanisms for implementing these protections. A Synapse firewall, a managed virtual network or managed VNet, networking restrictions, and data exfiltration protection, or DEP. Additionally, user security and RBAC is applied to Synapse and the data lake storage. Network security options, managed VNet. Microsoft managing the VNet takes away the need to manage the virtual network yourself. Indeed, there is no option to create your own VNet to use instead. Each Sparks pool runs inside its own subnet, which means that multiple Sparks pools running within Synapse cannot communicate, meaning any exploit in one pool does not expose other Sparks pools. It is recommended to use separate pools for separate functions. Restricts traffic to Azure resources, preventing data transit over the public internet. And the endpoints are created automatically to the serverless and dedicated SQL pools. The default storage endpoint for Data Lake, while created, must be separately approved in the Azure portal. Restricting public access via networking settings in the Azure portal will require some planning, and additional components will be required. An Azure virtual network to house the network components for private connections. Separate endpoints are required for SQL pools and Synapse Dev, where all artifact code will be stored. Other endpoints for storage and the Synapse workspace are also required. The Synapse Link Hub provides a mechanism to create private endpoints for the Synapse workspace. And in order to access, you must be within the Azure virtual network. VPN tunnels, point to site, or virtual machine operating as a jump box would satisfy this requirement. Network security options, data exfiltration protection, DEP. The most secure configuration that is possible to have on Synapse Workspace requires data exfiltration protection. There are some limitations which will apply to Sparks pools, whereby they will not be able to use services that require public endpoint connections. To implement access to public endpoints with DEP enabled, a range of additional Azure components are required. A customer VNet needs a connection to on-premise networks if it is to be used to securely read on-premise systems. A private link service provides a connection between the Synapse workspace and rerouting technology securely. The load balancer provides a front end for the private link and the backend servers. And the backend server uses forwarding rules to connect to public endpoints on their fully qualified domain names. Thank you for listening, and please look out for our next best practice pattern coming soon.